Hello and welcome to another Arlington High School Math 4 Honors lesson. My name is Kirk Weiler, and today we're going to be doing Unit number 1, Lesson number 4 on expanding and factoring expressions. As are all the lessons in Unit 1, this is a lesson that really serves primarily as a review from both Algebra 1 and Algebra 2, so we'll be moving through it rather quickly as we go. Anyhow, let's get right into it. So we're going to spend a little bit of time in Exercise 1 expanding expressions that involve multiplication. And so in Exercise 1, we're asked to expand and simplify each of the following, combine like terms when possible. So what I'd like you to do now is pause the video, take up to maybe even 10 minutes because letter C is actually kind of a lengthy exercise, and try to work through these. All right, let's go through them. So the first exercise, whether you use the FOIL acronym or whether or not you use double distribution, regardless, you have to know that this is going to multiply this, giving us 10x squared. This is going to multiply this, giving us negative 5x. The 2x has to multiply the 7, giving us 14x, and the negative 1 has to multiply the 7, giving us negative 7. We get 10x squared plus 9x minus 7. In fact, in my opinion, students at the 4 Honors level should be able to do that manipulation in their head. Now, letter B is very, very similar, with one big difference, right? Of course, we have 4 times 2, which is going to give us 8, but then it's important to note that root x times root x is equal to x, either because you know that squaring is the inverse of square roots, or because you apply an exponent property that says that when we multiply two things with the same base, we simply add their exponents. So we're going to get 8 times x, then we're going to have these two multiplying each other, negative 2 root x. These two multiplying each other, that's going to be plus 12 root x. And then these two, which are going to be minus 3, combine these like terms, which we often have to do, and we'll get 8x plus 10 root x minus 3. Again, probably a problem that students at the 4 Honors level can do in their head. Now, letter C, though, is significantly more challenging, and one that I doubt many students can do in their head, although some might. Now, the key to doing letter C is the key always when we cube something. If I have 5 cubed, right, or 5 times 5 times 5, well, then what I'm going to do is I'm going to multiply 2 of those 5s to begin with and get 25, and then I'm going to multiply by 5 again to get 125. Of course, that's not really the problem here. The problem here is cubing out a much more complicated expression. But still, at its essence, we've got the same idea. We've got 2x plus y times 2x plus y times 2x plus y. I have to decide on which two I'm going to multiply first. I think I'll just multiply those two first, and I'll keep bringing this 2x plus y along with me. I'll get 2x times 2x, which is 4x squared. Here I'll get a 2xy. Here I'll get a 2xy, notice those terms are identical, and here I'll get a y squared. We could then multiply through by this, but it probably makes some sense to at least clean up that polynomial expression by combining those two like terms into 4xy plus y squared. Now, there's nothing convenient in terms of foiling here, but what we can do is we just have to make sure that these two terms each multiply these 3 terms. So I'm going to just start with the 2x. Okay, 2x times 4x squared will be 8x cubed. 2x times 4xy will be 8x squared y. 2x times y squared will be 2x times y squared. Plus y times 4x squared will be 4x squared times y. Y times 4xy will be 4xy squared, and y times y squared will be y cubed. All right, now we look for like terms. There are no like terms for my 8x cubed, so we'll just do that. Here I'm looking for an x squared y. Here's an x squared y, so there are 12 of them. Here I've got 2 of these and 4 of these, so it gives me a total of 6 of them. And there's our final product. All right, that's essentially it, right? The golden rule is that when we're multiplying algebraic expressions by one another, each term must multiply each other term in the 2 expressions or the 3 expressions or what have you. all right? Sometimes they'll take longer, like in letter C, but most of the time we should be able to do them in our head. All right, pause the video now if you need to, and then I'm going to clear out the text. Okay, here we go. Moving on to the next page. All right, now that's all we're going to spend on multiplying expressions. Now we're going to get into factoring. Now there's four primary things, or four primary methods of factoring. There's factoring out GCFs, greatest common factors. There's factoring involving the difference of perfect squares. There's factoring involving trinomials, and then there's factoring by grouping. There's other types of factoring techniques, but those are going to be the main four for us. So take a look at exercise 2. It says factor the following by pulling out a common factor. It doesn't even necessarily say the GCF, but let's try to get the largest factor we can pulled out. So pause the video now and spend a few minutes trying these two. All right, let's take a look at letter A. Now, letter A is a little bit weird because of these fractions. An argument could be made that maybe we just leave those fractions in, but I should be able to actually factor a 2/3 out of both of those. Now notice this has an x to the second, this has an x to the first, so the largest thing that's common is x to the first, and then they both have a y to the first. So I'm going to pull out 2/3 xy. Then I ask a very simple question. What do I need to multiply this by to get this? And the only thing I'm missing is an x, right? So x times x will give me the x squared, but the y and the 2/3 have come out. On the other hand, what do I have to multiply by to get the 4/3 xy? Well, I have to multiply by a2, right? Because 2 times 2/3 will be 4/3, thus giving me my final answer. All right. Letter B is more challenging, but I want you to see the structure in this algebraic expression. You see, that 2x plus 1 should be looked at no differently than the y was in this problem, right? It is common to both. So I can certainly pull out a 2x plus 1. As well, this one has an x to the first, this one has an x to the third, so I can pull out an x. All right, what does that leave me? Well, I've already factored this out, but I have to have an x squared to multiply by x to get x cubed, and I have to have a 3 here. And that's it. All right. One could think a little bit about factoring this, and we're going to get into difference of perfect squares in just a bit, but that is not the difference of perfect squares. It could still be factored, like the difference of perfect squares, into x minus root 3 times x plus root 3, but we don't have to, and certainly if it was addition, then this would be what was called prime. All right. Pause the video now if you need to, and write down anything you have to. All right, I'm going to clear out the text. Moving on. Okay, use the difference of perfect squares to factor that and evaluate in letter B. Now remember how the difference of perfect squares works. It says if I've got an expression that follows this form, a squared minus b squared, then I can factor it as a minus b times a plus b. All right? So we just have to recognize that form. Two things that are both being squared and a subtraction. All right? So pause the video now and see if you can tackle both of these problems. All right, let's do it. Well, the first one's pretty easy, right? Because this really has the form of 9 squared minus xy squared. So this is just going to be 9 minus xy times 9 plus xy. Please make sure that you have 9 minus xy and not xy minus 9, unless you've also factored out a negative 1. Hey, my other computer just beeped. Lots of random sounds here at Arlington High School. Let's take a look at letter B. I love letter B. Take a look at this. I have 51 squared minus 49 squared. That's about as close to resembling this as possible, right? And that's going to give me then 51 minus 49 times 51 plus 49. 51 minus 49, that's a piece of cake, that's 2. 51 plus 49, that's also easy, it's 100. So we get 200. That's kind of a fun problem. In fact, I would suggest that you actually do that on your calculator just to also see the 200, right? Just 51 squared minus 49 squared, hey, it's 200. All right. So anyway, pause the video now. We're not going to spend much time on difference of perfect squares. Pause the video now, write down whatever you have to. All right, I'm going to clear it out. Okay, where are we going on this? All right, exercise 4. Factor each of the following trinomials. Make sure to verify your answers are correct by multiplying out the resulting polynomials. There is absolutely no reason to make repeated factoring errors at this level of mathematics. All right, so this is a message not just to my 4H students, but to any students who have been working with factoring trinomials for years. In my mind, there's one and only one good way to factor trinomials, and that's guess and check. All right. You may know methods with boxes, sums, products, groupings, all that. If you can use those, that's fine. But you have to be able to use them quickly, effectively, and without a calculator. So if you can't do that, then guess and check, right? Let's actually do letter A together, and then I'll have you do letter B and letter C on your own, right? So if I don't think this is prime, if I think I can actually, factor it, then in my first two blanks, I have no choice. It's 2x and x. Now, of course, 6, there's lots of possibilities, right? There's 2 times 3, there's 1 times 6, and the question is, well, which one goes with which? All right, so I'm going to point out a way to make an intelligent guess and check. So one possibility is putting the 2 there and the 3 there, and it seems reasonable because, you'd have you'd have 2x times x, which would be 2x squared, and then 2 times 3, which would be 6. But here's the key. Notice that this binomial now has a GCF in it, right? A GCF of 2. But the trinomial doesn't have a greatest common factor. Look, this is like prime factoring a number. A factor is a factor no matter what order you do it in. So if the overall trinomial does not have a GCF, then none of the binomials can either. So that's actually a nonsensical guess given that that's still not working. Let's try that one more time. Given that the original doesn't have a GCF, we can't put the 2 there. And that's nice though. That forces us to put a 3 here and a 2 here. Let's just take a look at something. That's going to give me 4x. This is going to give me 3x. And I can get those to come out to be negative x as long as the 4 is negative and the 3 is positive. And there it's correct, right? That gives me that negative x. So there's my final factored answer, 2x plus 3 times x minus 2. What I'd like you to do now is pause the video and do B and C. Remember those intelligent guess and check schemes. Okay? Go for it. All right, we're right back to it. So let's take a look. And again, think about this for a moment. Right, we've got 6x squared minus 17x minus 3. So 6x squared is a little bit trickier because we could have 6 times 1 or we could have 3 times 2. All right, let's go with the 6 and the 1. 6x and x. Now the 3, well, that's nice. It's just 1 times 3. But remember, there's no way it could possibly be this, because if it were this, then this would have a GCF of 3. And since the overall trinomial does not have a GCF, none of the binomials can either. So there's no way that that's the right answer, and I don't even have to check it. But let's try to put the 1 here and the 3 here. Now notice, here we would have 6x times 3, which would be 18x. Here I'd have 1 times x, which would be 1 times x. Now, can I make those into a 17? Negative 17? Sure I can, as long as the 18 is negative and the 1 is positive, and I'll get that if that's a negative and that's a positive. There we have it. That kind of looks a little bit like 6x plus 11 and x minus 3, which I did not want. I just want 6x plus 1 and x minus 3. All right, did you get C right? Well, I'm running out of room. Now again, don't be thrown off by the y, that's okay. 20x squared, well, 20 again is tough because it can be 1 times 20, 2 times 10, 4 times 5. If I have no idea, I generally start with numbers closer to each other, like 4x and 5x. Now, one thing that is nice is 2y squared is easy. That's going to be 2y and y, right? There's no getting around it, and the 2 can't go here. So I do this, 2y and y. Let's take a look. 5xy, 8xy. When you add those together, you get 13xy, so that's the correct guess. And there's our final answer. Right? So, intelligent guessing, quick checking, right? And just repeated guess and check until we have it right. All right? Anyway, pause the video now and copy down anything you need to. All right, I'm going to clear out the text. And let's move on. All right, so our last type of factoring is what's called factoring by grouping. Factoring by grouping. Factoring by grouping is probably the least useful of them, but it does come up on occasion here and there. All right, but it's very, very specific. So let's actually work through the first one together, and then you can work through letter B on your own. So in letter A, the way that factoring by grouping works is often when there are 4 terms. 4 terms, okay? 1, 2, 3, 4, 1, 2, 3, 4. It won't always work if there's 4 terms, but it often will. So what I do is I group the first 2 together, and I say, well, what can I factor out of that? Well, I can factor an x out of both of those, right? And it'll look like this, x times x minus h. Now what I'd really like to do is factor something out of these 2 terms that also leaves me that x minus h. This one's actually a little bit tricky. I have to factor a -1 out. And if I do, I'll be left with x minus h. But now notice that the x minus h is itself a greatest common factor. So I can factor that out, and then what I'm left with is x minus 1. So I get x minus h times x minus 1. Kind of cool, huh? All right, why don't you try letter B? Pause the video for a second. All right, let's go through it. So, same song, second verse. I'm going to look at this and I'm going to say, well, I can factor an x out of both of those, and that's going to leave me an x squared minus 16. All right, here I can factor out a positive 5, and that's going to leave me with x squared minus 16. So now the x squared minus 16 is my GCF, and I factor that out, and what I'm left with is x plus 5. Now we can go a little bit further here because that's the difference of perfect squares. We can rewrite it as x plus 4 times x minus 4 times x plus 5. And that's what's called complete factoring. We have factored until we can't factor anymore. All right? So, pause the video now and write down what you have to, and then we'll move on to the last exercise. All right, here we go. Oops. Nice little streak there. Moving on. All right, exercise 6. Completely factor each of the following expressions. Recall that e is the base of the natural logarithm. All right, ooh, these seem like challenges. So what I'd like you to do is actually spend a little time and try to factor these. See what you can do. All right, well, it's got to be factoring that we've already seen today. So take a look at letter A. This is actually a trinomial. Now please note that e to the x times e to the x, we would just add those exponents, and we'd get e to the x plus x, or e to the 2x. What we don't get is e to the x squared. That doesn't happen here. All right, so what's kind of cool is that in a certain sense, this problem is structurally the same as x squared plus 4x minus 21, right? If I had x squared plus 4x minus 21, I wouldn't even bat an eyelash. I'd just say x and plus 7 and minus 3, right? That would be this guy. On the other hand, this one is structurally the same, and I would just have e to the x plus 7 minus 3. Right, it works out, right? 7 e to the x minus 3 e to the x, add those together, 4 e to the x. So check, it works. All right, I'm going to actually erase this. I have more room over here. Now, in this last problem, right, we can actually do some GCF factoring. there's definitely a t that I can pull out of both of these, and there's definitely an e to the 2t I can pull out of both of them. Now once I do that, all that's left in that first term is a 25, and all that's left in the second term is a t squared, right? Because I pulled out a t from a t cubed, I'm left with a t squared. Now this is actually the difference of perfect squares, so I'm not going to lose my initial factors. And this I'm going to write as 5 minus t times 5 plus t. And that's it. All right, so pause the video now if you need to, and write down any work you have to. All right, let's clear this out and finish up the lesson. So in today's lesson, basically we did some very simple review on how to multiply out polynomials, how to expand, as the term is, and then how to factor using our 4 major factoring techniques of common factors, differences of perfect squares, trinomial guess and check, and factoring by grouping. All right? All of these techniques are going to become important, especially tomorrow, as we move on and we do work with solving equations using the zero product law. But we'll have to factor in other contexts as well, so it's not just from an equation solving perspective. All right. Well, I'd like to thank you for joining me for another Arlington High School Math 4 Honors lesson. My name is Kirk Weiler, and until next time, keep thinking, keep solving problems.